Hello and welcome to part 2 of step 11. So we're going to still use the Pythagorean theorem in this step, but we're going to take a slightly different turn, okay? So the first thing we have to establish before we start these problems is whether or not the sides of a triangle can actually be a triangle. So we have to take two of the sides, add them together, and that has to be greater than the third side. So let's just do an example because I think it's easier to see an example of than try to explain all those inequalities. Okay, so we have potential sides are 8, 15, and 17. So we have to take two of the sides and it has to be greater than the third. So let's try 8 plus 15 greater than 17. So 8 plus 15 is 23, and that's greater than 17. So that one works, okay? But we have to do it 2 more times with the other 2 combinations. So let's try 8 plus 17 is greater than 15. So 8 plus 17 would be 25, and that's greater than 15, so that one works. And then we have, last but not least, 15 plus 17 greater than 8. 15 plus 17 is 32, which is greater than 8, so that works. So all 3 of these inequalities work, so we can say, yes, this can be a viable triangle. Okay, but we have to check all 3, and if there's one that doesn't work, then it can't be a triangle. So for example, if we look at the next one, okay, we could start, let's say, like 6 plus 14 is greater than 8. Yep, because 6 plus 14 is 20. That's true. We could even do 8 plus 14 is greater than 6. 8 plus 14 is 22. That's greater than 6. Perfect. But when we get to 6 plus 8 to be greater than 14, 6 plus 8 is 14. So that is not true. That does not work. So we can say, no, this cannot be a viable triangle. Okay? So if we can have a triangle of those 3 sides, we have options of, can this be a right triangle, right? If it's a right triangle, then it's going to follow Pythagorean theorem, because Pythagorean theorem only works for right triangles, right? If the a squared plus the b squared actually equals the c squared, it is a right triangle. But that's not always the case. So if we have sides that are a triangle, then we have to check. So if the c squared is bigger, then this is going to produce, if the c squared is smaller, that's how you read that inequality, it's going to produce an acute triangle. But if the c squared is greater than the a squared plus b squared, it's going to show an obtuse triangle. Okay, where that c is going to stretch the figure into a bigger angle. Okay. Remember, acute means that all angles are less than 90 degrees. Obtuse is we have one angle greater than 90 degrees. Okay, so let's do an example of this. Okay, so determine whether each set of numbers can be the measures of a triangle. So let's do that first. So 7 plus 14, is that greater than 16? Well, 7 plus 14 is 21. So that's true. 7 plus 16, is that greater than 14? 7 plus 16 is 23. That's greater than 14. Good to go. And 14 plus 16 is 30. That's definitely greater than 7. Oops. So we can tell from our inequalities, yep, this can be a triangle, but we still also have to say what kind of triangle. So we're going to set up our Pythagorean theorem. Okay, we're going to pretend that the biggest side is still going to be our hypotenuse. We're not sure if it's actually going to be a hypotenuse in a right triangle, but we're going to assume that it is. The other two sides can just get plugged in. Okay, 7 squared, 7 times 7 is 49. 14 squared, 14 times 14 is 196. And 16 squared is 256. So 49 plus 196 is 245. So you can see, obviously, 256 is greater than 245. So if we follow that inequality back up, we can see that c squared, that hypotenuse, that pretend hypotenuse, is going to be greater than the a squared plus b squared. So if the c squared is bigger, that's going to produce an obtuse triangle. Okay, and that is all for step 11. Thanks for watching.